One.
Hi guys, so our final project is stock picking, and I'm working with my partner Minseok. So now we're going to go to each aspect of the project.
So our objective is to use the data provided by the Dow Jones, and we will use the metrics and the indicators out of the 20 years of data starting from 1999 to 2019, and we will compare our results with the benchmark return provided by Dow Jones Industrial Average. And if it exceeds the point, then we could probably mark that stock as successful.
And I'm going to talk about the pre-processing that we have done. So it's really hard to find an existing data set that contains all the metrics as well as the stock information from the past 20 years in Dow Jones. So we pieced together both the stock information as well as the metrics, the feature variables. And as you can see, there are still some NAs left on the data set. So we did some further processing, pre-processing by eliminating the NAs and replaced with zero. And we also did use standard scalar for all the feature variables. So after that, we used PCA as well as correlation matrix. So as you can see, we have about 20 in total, about 24 variables. But as you can see, if we have 15 PCA, we're already getting into the 95% interpretability. And in terms of the coefficient matrix, there are a few spots where variables have high correlations. Correlation matrix, sorry. In that case, we're going to look at the variables and see how they interpret in the finance setting, as well as how it correlates with other features, and decides which one to eliminate from there. And in terms of the models, we're going to use k-fold cross-validation a lot, and we're going to use it in both elastic net as well as random forest to choose the optimal set of features as well as the optimal parameters. And in terms of elastic net's model, we're expecting a high interpretability, but it's going to be a little weak compared to other models. And in terms of the random forest model, is going to have a better performance, but we can't really get much information out of it. So we're going to use both to understand the characteristics of the stock we're buying and selling. And now we're going to go to another model that we're using called the LSTM.
Well, because when is also important as well as what in buying and selling stocks, we'll be implementing a time series forecasting model called LSTM, and it stands for long short-term memory, and it's a type of random neural network model. So LSTM models are able to store information over a period of time, and that's why it is effective. It is able to store past information that's important, and if it's not important, it can forget about it. And this characteristic is extremely useful when we deal with time series or sequential data such as stock prices or housing prices. And we'll be able to decide what information will be stored and what is discarded by using the three gates. There's the input gate, which adds information to the cell state. There's the forget gate, which removes information that's no longer needed. And there's the output gate that selects the information that is to be shown as the output. And we'll be able to use LSTM to determine when to buy and sell the stocks chosen using the other models for maximum profitability.
That's all for our presentation. Thank you so much for listening.
Thank you very much.